Hi folks, in today's video tutorial I'm going to show you how to work with dynamic analysis. I'd like to continue on the previous mechanism what we have created, so please check my YouTube channel, and the mechanism was rocker Bogie system. So the last point what we have done in that video was that we have placed the rocker Bogie system in the assembly, placed it on the pad, and then we have created camp connections. What is necessary to do, that it is not only about the connection between surfaces from the wheel and surfaces from the pad, but in this video tutorial I'm going to explain two details about the dynamic properties and dynamic analysis. We need to create this modification 6 times. What does it mean? If you would like to know more about these dynamic properties, please visit my webpage 4ksite.com, jump into Creo Tutorials, and over here you have how to apply lift-off and friction. The system automatically jump to YouTube channel to selected video, so please have a look and try to understand the definition what I would like to use right now. Okay, and if I would like to change it a couple of times, I do not want to do it 6 times, so I will help myself with map key. So I will run the map key and I will create a temporary map key. Yeah, so I will select map key here. You can see that I have a couple of them, and I will create a new one. I will run it with Q temporary map key. So it's not necessary to define name and description, only we would like to record the map key. So first of all, it's necessary to select the feature, and then it's possible to record the map key. Yeah, so first of all, it's necessary to select the definition, and in the properties tab I would like to apply lift-off, for example 0.3, and enable friction, so 0.8, and the second one, dynamic and static friction. If I would like to confirm OK, the system record this modification for me a couple of times. Yeah, and right now I would like to do it on the other. So select second camp feature and use the map key, for example Q, and the system will apply it. You can check it at the definition and you can see that everything is applied correctly. So another one, map key Q, another one, map key Q, another one, map key Q, and last one, map key Q. So you can see that apply or modify the feature with map key is really easy and really quick. Again, for the checking, everything is fine. Yep, same as I need. Okay, so camp connection is right now defined with the friction and the lift-off. So what does it mean? Please visit previous tutorial. We need to continue. What we need to define, if we would like to move the rocker Bogie system, we have to create the servo motor. You can select this arrow because you know that subassembly rocker Bogie system was placed as the plane connection. So you can select this arrow and use the servo motor. I will jump directly to properties tab because you know that we would like to use the velocity. And we would like to move, for example, 500 millimeter per second. And do you remember that it's approximately 15 meters, so it's quite good enough. So 500 millimeters per second, confirm OK, and the system created for us the servo motor. It's here. What we need to do additionally is create additional condition. So you can create and drag components and specify the placement. You can take a snapshot and system will take a snapshot and confirm OK. What does it mean? If I will create new initial condition, I can use the current screen, or I prefer to use the snapshots. Again, you can define angular velocity and so on, so please try to have a look, or we will focus in another video tutorial. Okay, So right now, summary, cam connection is ready, rocket Bogie system is placed correctly, we have specified a servo motor, and we have initial condition. What we missed is the analysis. Again, we can create a new analyze feature. We don't want to use the position but dynamic, and we would like to specify duration that approximately 20 seconds, and frame rate will be detailed. It will be 30 seconds, not 25 like I use always. Don't forget to use the initial condition state. Default is 1. Yeah, remember that we have created here. In the second tab is motor. We have specified motor. We would like to start from start to end, so it will be 20 seconds. At the end is possible to set external load. We would like to use the gravity, default is set, and enable all friction. Why I would like to use the friction? Because we would like to spin the wheels. Yeah. Right now we can have a look and run analysis. What was wrong? I don't change the orientation, so please have a look on the motor, and I will go to edit definition tab, and you can see here that my motor going on the left direction, so it's not good. We would like to go on opposite right. So I will use the flip function. Right now the side is okay. Confirm, and we will run the analysis one more time. Yeah, this time we'll run from initial condition. Run, and yes. Right now it's okay. Okay, analysis took a couple of seconds, and right now we would like to see the final results. So in the playback, you can expand playback, and by run function or play function, you can manipulate, you can visualize, and you can capture in your AV file, for example. I have specified some definitions, so we can run the analyze. You can increase the speed, and for example you can have a look that everything is spinning, so our wheels are spinning correctly. You can turn and visualize it. Yeah, for example, this wheel was lift off outside of the path, so the speed was so quick, and again over here, yeah, that system jump up and down. So it's about the value of lift off what you have specified. Okay, we would like to make some additional measurements. We will jump to measure function, and I will create a new measurement. So create new. You can specify the name, for example position 01, that's not about the name, and you can specify pointer motion axis. So for example we would like to see the position of this point. Yeah, so select the point, and you can specify magnitude XYZ. We know that we would like to see, for example, the Y. If I will confirm OK, the system allowed to me to select the measurements and analyze the results, and you can use the function see the graph. The system will show you all necessary information and the measurements, how the wheel was moved, or better to say it, the points what you have selected. So you can select and create more points, and you will see all necessary analysis definition here. But we don't want to see only the position, yeah, because for example you would like to know something about the speed. Yeah, so we will create new measurements. I would like to see, for example, the velocity. You can see that it's possible to select the additional type of the measurements, so we would like to see the velocity. Again, for example, same point. Yeah, so this point, and I would like to see the magnitude, not only XYZ but magnitude. So what is defined in XYZ orientation directly and each step. If I will come from OK, you can again select and see the graph, but what I would like to show you before ending our tutorial is that you can select the playbacks here and select icon, and system allow to you display arrows. If you will select the measurements and you would like to see the value, and you will run, the system will calculate everything for you. And again, you can increase the speed and you can see the magnitude. The system can allow to you to see the orientation and direct measurements. I hope so that you like my tutorial, so stay tuned and see you later. Bye bye. Vladimir.